for this class. So we are on schedule. Macam on schedule, macam pilot Asia yang cakap kan on schedule. Okay, what you need to do for next week is, of course, you can relax a little bit, but don't forget to complete your assignment, because once you come back, the second half of semester we usually pack with assignment, and you have a lot of assignment, and because now it's already face to face, and you are probably required to do oral presentation and so on, so you have to prepare on that. And especially for Chinese students, you have to plan well your Chinese New Year holiday, because most probably you will have some course for your final exam, okay, for final exam right after semester Chinese New Year. So you have to plan that. Like if you are probably from very far from Unimas, your hometown is very far from Unimas, you have to plan well on that, okay? Because the final exam schedule will usually come out probably 1 or 2 weeks before the final exam week. So it's very difficult for you to really book your ticket. Okay, it's very difficult to. I mean, you can probably shorten if you want to go back for your hometown for Chinese New Year, then you have to really shorten the traveling time. So that, but once again, Chinese New Year is once every year. But the final exam for this course is once in your lifetime. Okay, so cakap banyak ni, so I think we can start. Okay, the rest of QR attendance I will show again. Okay, I will show again that during the semester during the break. Okay, so yeah. So this meeting is recorded, and hopefully you don't mind. Okay, so we continue with this. We have 2 more example for this cylindrical coordinate. Okay, so what we need to do here, is just observe how the x and y and also including z move. Okay, so from here you know that the outer limit is from x from 0 to x equal to 1, and you have y is from 0 to y equal to 1 minus x power 2 square root. Then you have this z is from x power 2 y power 2 to z equal to 16. Z equal to 16. Of course, this step is not that necessary, but this is the way that I solve this triple integral. So you may skip this if you want. Okay. But this is very easy. If you have this, then you can observe that you know that this is a positive, and this is positive, and we don't have to square root both sides. But you know that this will give you a circle, or this will give you part of the circle. Okay, where you know that the radius is 1. Okay, I hope you can see here is already. You should be able to see that this is radius 1. You don't always have to square both sides, okay, power 2 both sides, but you know that this is a circle. It is a circle. It's a circle. Kelvin Wang, you have to switch off your microphone. Otherwise, I can hear echo. Okay, a very strong echo. So here we have this circle. We have this circle, and this tells you that this is just y is always positive. Y is always positive. This gives you this square root. And but whether we take this first quadrant and second quadrant together or not is depend on the x value. So the x is from 0 to 1. So meaning to say that we take this part. We take this part. So if we take this part, then you should know that this will give you theta from 0 to pi over 2. And this should give you r from 0 to 1. 0 to 1. So these are the limit that we will use for theta and also r. Then we convert this everything to r power 2. We convert that to r power 2, and then you can write down this. You have to copy this one. Is just equal to a limit from theta from 0 to pi over 2. Then you have r from 0 to 1, and this z is from r power 2 to z equal to 16. Here you have x power 2. You have x power 2 here. Remember this x power 2, we have to change to r cos theta, everything power 2. And by itself, you have your dz r dr d theta. Okay, if you manage to get this line, then you can get a lot of mark here, and together with this, okay, and together with this diagram. So when you read this triple integral, and if you want to change to this cylindrical coordinate, the reason behind this where we change this to cylindrical coordinate is you can try to integrate this. You can try to integrate this. Somehow it's not that easy to do integration because you have the something search here. Okay, you may try from here from this. You go for dz, de, dy, and dx. But I believe that it is not that easy, and the integration will become very complicated. So that's why we put it into a cylindrical coordinate, and we have slightly easy integration to do, especially when it comes to r and also pi. Integrate with respect to r and also with respect to theta. Also, that's the reason. So a common mistake is this: you cannot determine correct theta and r. And another common mistake is you do not change this x and y to r. And of course, another very common mistake is you forgot about this r here. You forgot about this either at the very beginning or when you do the what you call the integration, then you forgot to add in this r. So those are the common mistakes. Okay. So what we do here, when you notice that when you differentiate with respect to z, or when you integrate with respect to z, there is no z at all. So in other words, here this r cos theta power 2 everything are just constant. Everything are just constant, so you may put it somewhere else by writing down r power 3 cos power 2 theta, and you have this everything integrate with respect to z. You get a z here. It is from r power 2 to 16. R power 2 to 16. So this is dr d theta. Notice that this is the much more proper way to write the double or triple integral. Okay, then you have this from 0 to pi over 2, and this everything you have 0 to 1, and here you have 16 minus r power 2. So I straight away consider this into here. You have your this. I better put it this way. This alone, if we give you 16 minus r power 2, this is in bracket, so you multiply with this r2, r power 3, you should get this is 16 r power 3 minus r power 5. Everything, it is the cos power 2 theta d theta. So this remain constant, and you may just solve this part here by using, you can use calculator or you can use manual integration. Okay, so you can compare your answer with my answer. So I factor out the cos power 2 theta. So this part, everything, you can use calculator, 16 r power 4 over 4 minus r power 6 over 6, and from 0 to 1, and d theta. Can someone give me the answer for this part only? I don't have calculator with me, very bad. Oh, no answer. No response. What is this answer? Oh, I'm too fast. Still calculating. I guess this is 4. This is 4 minus 1 over 6, so it should be 25 or 23. I hope this is the correct one. 23 over 6. So I don't have calculator, then I managed to get this. I hopefully this is the correct one, but you use calculator. Use calculator for this. Is this correct? 23 over 6. Yeah, thank you. Okay, thank you. From Kyobing and also Rebecca. So here you have 23 over 6, and here, so what's remain here is from 0 to pi over 2. But the cos power 2 is something that, whether you like it or not, you have to use this. You have to use this, I type it somewhere else, which is cos 2 theta equal to 2 cos power 2 theta minus 1. So this go for this as well. If you have sine power 2 theta, then you have to use this. Okay, so we are using this formula to integrate cos power 2 theta. So here you have your cos 2 theta plus 1 divide by 2. Divide by 2. And this is d theta here, d theta. So always remember that we have to apply this formula. You have to apply this formula to get this one. So there will be 1 mark for this applying this formula here. Then you can do your integration now. Everything is 23 over 12. So this everything cos, you get sine. Remember, you get sine 2 theta, but be very careful. If integration, you have to differentiate this with respect to theta. You get the 2 and you put it as the denominator. Then we have plus theta again. Plus theta from 0 to pi over 2. And this will give you 23 over 12. Here you will have sine pi over 2. Sine pi over 2, because pi over 2 multiplied with 2, you have pi plus pi over 2, and the rest will be 0. The rest will be 0 because you know sine 0 will be 0, and this is also 0. So you can also say that this is 0. Sine pi is 0. And so what's remain here is this answer. You should be able to get this. 24.5. So if you need to take a screenshot on that, yeah. Is it okay? So I give you 1 minute to digest this one. Any question on this converting to cylindrical coordinate example? Okay, no question from Jabing and also Rebecca, Veronica. Thank you. Thank you for response. I know it's not easy because you have to. I'm not sure whether you just print screen or you just you have to copy down this, and also at the same time you have to communicate through chat room. I think, but you are IT generation. It shouldn't be a problem. Okay, so back to this. If no question, then I move to another example on cylindrical coordinate. So be very careful. I think in many cases we will encounter this. We will encounter this cos power 2 or sin power 2 theta. So this is the formula that we are going to use. Okay, but unfortunately, for my test 2 and also final exam, there will be no formula given. Okay, because I cannot give you that this and you know that you must arrive at this cos power 2 and something like that. So for this type of identity, I expect that you find a way to memorize that. I can memorize this because I know that this is try to link between cos and sin power 2 with put it to cos 2 theta. Okay, and I remember that 1 is something 2 minus something, but 1 is 1 minus 2. But so I remember as this is sin s minus, so it should use minus. Okay, it should use minus first and then go for this. I remember that way, so I go for 2 cos first, so not the minus first. So this is minus first because sin minus, yeah, something like that. So that is my way lah. Okay, to memorize that. Okay, so if no question, allow me to move to the next example. Okay. So this example is include mainly to tell you that we may have something slightly different. We have 6 different solid as we go for 3D graph. So this might something this equation you did not encounter that or where you call it ellipsoid. So ellipsoid is something to do with ellipse. Okay, so what's different between this equation with sphere? Okay, or if you still remember sphere, or what is the differences between this is now you see that there are the coefficient for this, they are not the same. These are 4, 4, and these are 1 here, and these are 1 here. So they are not the same. So it is not a sphere. Or what you know about sphere here? If they are the same, then you have this. Let's say you have this. This is a sphere. Okay. This part here, as you can see, even though we didn't draw it as sphere, okay, as a circle, but this is really a circle. For a sphere, then these are really a circle. But for ellipsoid, it is not. It is not. This part here is an ellipse. I'm not sure whether this is something, but this is an ellipse. I better put it like that. these are ellipse. Okay, but to make it easy, this ball is your football, is your whatever basketball, but this ball, this, if you say that this is a ball, that it should be how am I going to pronounce rugby? I hope I spell correctly. Okay, this is a rugby ball. Rugby ball is the ball that you use in rugby is an ellipsoid. Okay, hopefully you in fact our Earth, okay, is also ellipsoid. Okay, is also ellipsoid. It is not sphere. So then with that, okay, hopefully with that, you don't be scared by this ellipsoid. Okay, so what you have to know that on this is that it's very similar to a sphere, just that you have this part here. How you are going to draw this when notice that when the z is equal to 0, okay, when the z is equal to 0, this everything you have 4x power 2 plus 4y power 2 equal to 16. So in other words, here you have x power 2, y power 2 equal to, you divide both sides with 4. You divide both sides with 4. So that this part here you have 4, which is 2 power 2. So it still use that this is 2 and 2. Of course, this is not in proper scale. This is 2 and this is 2. X and Y and Z. Okay, hopefully you can follow. We sketch this by Z equal to 0 here, and you have this by letting this Z equal to 0, then you have you can find that the circle is actually, it is a circle. It is a circle. Okay, but you know that the rugby ball, it can be ellipse can be here or can be here as well. Okay, can be here as well. Where you have, for this case, if you say your x and y is equal to 0, if you let your x and y equal to 0, this is let, this everything you let it as 0, then you find that the z here we give you 16 and plus minus, so you know that it is plus minus 4. It is plus minus 4. So here 4 should be higher than this, and this should be slightly lower than this one here, negative 4. So if you connect that, you should see that this is no longer a sphere, but a rugby, something like the rugby ball. It is right. So, okay, of course, the rugby ball, you can hold it this way. You can also hold this way. You can also put it like macam berdiri lah. Okay. Is it okay? That's we illustrate. We don't have this, but this, I would say that this is, if you ask me to categorize this one, I will put it under sphere as well. I will put it under sphere. Hopefully we have different variants of this second category. We have cylinder, we have sphere, and we have also ellipsoid. Is that okay? Okay, good. Thank you. Thank you for response from Veronica. Okay, then we proceed with this. We want to find volume. Okay, we want to find volume. Of course, this one you have to come down. You have to give it projection regions. Okay, so this is the projection regions. From these projection regions, you know that, okay, you know that the theta, I'm not going to write here again, straight away right here, theta. Okay, before that, don't forget the word first order. Okay, first order. So first order refer to, we are just focused on this part. We just want to find the volume of this, so we are just focused on this part. First order, this is here. Unless if it is not, then we have to go for all that. We have to go for all of this. This is only for first order. Remember to read carefully the question. So if it is first order, you know that it is up to pi over 2 only. Then you have your error. Error is from 0 to 2. Error is from 0 to 2. Then the jet here is starting. Jet is something like you may use a 3D strike if you want. If you want to use a 3D start, enter here and leave here. Leave at this surface. Leave at this surface. So how to capture that surface is you have your jet equal to 0 and you have equal to jet equal to something. Jet equal to whatever here. You have to do some extra work to put that this becomes z power 2 equal to 416 minus 4x power 2 minus 4y power 2. Then what you need to do next here is to square root both sides. Okay, square root both sides. So that this part here you have z equal to 16. I straight away put here as x power 2 plus y power 2 square root. Okay, and so that we can say that this is error power 2. So these are some extra work that you need to do. I repeat, basically the idea is to write the jet as a subject of formula. So the way that you just rearrange this one, you rearrange this carefully, and you square root both sides so that to get the rate of this power 2, and then you change this by using the conversion formula. So altogether there are 3 steps. Okay, these steps are very important so that you can arrive at this part here is 16 minus 4 error power 2 square root. Then you have, remember for volume, we put it 1, so you have dz error d error d theta. So I give you some time, 1 minute to digest this one. Any question? Okay, thank you, Joving and Rebecca. And yeah, Lucas just joined us. Okay. And this day, when I come to campus, come to faculty, I feel that okay, our faculty become quiet again without all of you, for 2 weeks, 2 weeks and 2 weeks more. Our faculty have been very quiet for 2 years already. For 2 years, then you all came back in early October. Then become energetic. But now it's again very quiet. So the important is very important. Without you, yeah, our faculty is little bit full of all people. Okay, so I hope you can get this. Okay, I hope you can get this. Pi over 2, everything, especially this part, So, not that easy to integrate this, but a little bit lazy to write down all and just focus on this part. So what you have here, this is your jet, everything from 0 to 16 over r power 2, 4r power 2. So here you get your 16 for r power 2. Remember to consider your this r to when you integrate for the next for r. It is 16 minus 4r power 2 r d theta. Again, we don't like this kind of integration. I believe you know that this one you have to go for substitution. Okay, so please practice this. Please practice this, and you for sure you will be tested on this. Okay, because this is what you call for this, you have to, whether you like it or not, you can only solve this by using substitution. You can solve it by using substitution. And then you have du dr equal to negative at r. Be very careful of writing down this is r dr du over negative at. This is probably the third or fourth example that we do this already. So don't tell me that you have no idea at all how to do this. Okay. So you must have some idea on at least doing the substitution. Then after you do substitution, you have to be very careful. And one skill that you need to have here is to write this u become 1 over 2. Index, you put it at index power 1 over 2 so that it is easier for you to do integration later on. And this r dr you just replace with this du over negative at. Always remember that substitution is to reduce the integrand, become something easier for you to integrate. And this part here, you can factor out negative 1 over at. And here you can have your, do it carefully, the index will be plus 1, so u 3 over 2, and this everything you have 3 over 2. 3 over 2. Write it clearly, and you should see that this and this can be cancelled. You should notice that the pattern, the pattern are more, not the pattern, I would say the pattern is more or less the same. Whenever you do have this, you do this kind of substitution, you always find what is r dr, and you always have to do something this very, what do you call, this you have to put it this way, involving a lot of fraction. Okay, the index is fraction, the denominator is also fraction. Okay, so you have to deal with that. Then be very careful, you have negative 1 over 12. So this thing you have to put back your u, which is this one. Your u is this one, you have 16 minus 4 r power 2. And then you have 3 over 2 index, okay, the power, and you have 0 to 2. You have 0 to 2. You may wonder why this is negative. You may wonder why this is negative here. Okay, I highlight this negative. And you know that volume will never be negative. Volume will never be negative. Then you should have a target that somewhere later on, when you substitute this 2 and 0 into here, there must be a way for you to eliminate this negative. Otherwise, it is not that correct. Okay. So be very careful of that. Okay, so we still have negative 12. But when you substitute the first one, 2 into here, be very careful. 2 power 2 is 4. 4 multiplied with 4 is 16. So 16 minus 16 is 0. You get whatever 0, whatever the index here, the power here is not that important anymore. Okay, the first one you get 0. I repeat, you 2 put into here, 2. Then you have your 2 power 2 is 4. 4 multiplied with 4 is 16. 16 minus 16 is 0. Okay, so you have that. Then the second one, when you substitute 0, it is not always 0. When you substitute 0 into here, you did everything 0 already. So you have 16 power 3 over 2. 16 power 3 over 2. This 16, of course, you can use calculator. Otherwise, you may say that 16 is just, this part is just your 4. This part is just your 4 power 3. 4 power 3. Because you know that this is your 16, you find the third here, it is become 4. So 4 power 3, you know that this is 64. So we have 64. This minus and this minus can be cancelled off, okay, because these are negative, these are also negative, it cancel off. So this is the what I say, that you have to know that it is a volume, so you will never get negative. So this is 64 over 12. Of course, you can put it simple form. I can remember that this is 4. Can I use 3? Can I use 3 to that? This is 4 and this is 1. This is 16. I hope this is correct. I don't have calculator with me. Very bad. Yeah, Kelvin. No question, huh? Correct, huh? Kelvin say no question, and Faris tell me that this is correct. Okay, thank you very much, Faris. You made me confident in doing mathematics. Veronica, are you okay? Yeah. I hope your line is okay. If you have very limited internet access, then you may watch the recording later on. But not much interaction. Recording not much interaction. Yeah, Faris yang memberi saya keyakinan. I say, oh, correct. This one correct. Okay, back to this. You have the 16 over 3. This part here, what I can say is you have to be very careful. You have to be very careful in doing this all the calculation. So a slightly mistake that will lead you to will not give you the correct answer. Have to be very careful on that. So here you have 16 over 3. So this one here becomes 16 over 3. So this is 0 pi over 2 and everything is d theta. And you don't have to do much on that. You know that the answer here will give you pi over 2. So the answer here will be 6, will be at over 3 pi. I hope that this is the correct answer. Yeah, correct. Oh, this is at over 3 pi unit power 3. So if you need to type, I have to reduce this because some of you may need to print screen this, and I was informed that you can't see what is into below here. Is it okay? So I give you 1 minute to ask me any question, if you have, okay? And I probably we have to go for a 5 minutes break before we continue with spherical coordinate. Okay, if no question, we have a break for 5 minutes, and I show you the QI attendance. Break for 5 minutes. Okay. I hope you are back in front of your laptop. So we continue with this triple integral in spherical coordinate. I would say this is the most challenging coordinate to use. Okay, because it involves a slightly different parameter. Okay, we have to go for parameter first, one by one. You can look at here. Oh, so very bad. Again, before I start here, the spherical coordinate is something. Okay, yeah, before that, before I have to jump back into here, I forget to tell you that this question, okay, this question, if we do not have this octant, the first octant, if we do not have the word first octant, meaning that you need to find the volume for all this, then you have to be very careful. The changes that you met here, if it is for all, then this is no longer this part, but all here, then you have to change this to 2 pi. That's the first thing. Okay. And the second thing here, if we want to find the volume for this, okay, the first thing is to change this pi over 2. The rest maintain the same. Maintain the same. And you have your 2 pi here. But again, this is the same thing as symmetry. There is no way for you to get this volume for all this by just consider the projection region of this. You can only find half of that, either the upper part or lower part. Because of the projection region here, it does not really reflect the whole ellipsoid like that. It's only reflect that it is either upper part or lower part. So what you need to do here is you have to add these two. It did make sense to you because whenever you use this projection region, it is just upper part or this is just lower part. Did it make sense to you? Okay, thank you, Rebecca. Okay, I'm cubing as well. Okay, back to this one. So back to this spherical coordinate. Okay, I will start with this. This spherical coordinate is not used for only sphere. As you can see here, later on we have cone. We have cone here too. You can also use this spherical coordinate. But what is important here is this rho parameter. I will go for this one by one. So you look at this rho parameter. These are very similar to R, but not R. I hope it makes sense to you. Why I say that this is very similar to something in R, but not exactly R. Okay, what is that rho mean? If we have a rho, okay, rho here is something that if you read from here, this is rho. Rho is something measured from this origin to the surface in the z-axis. Okay, what does that mean? If I tell you that if I have a sphere, so this is a sphere, you can say that this, you know that this is your R, this is also your R. They are just the same. In this case, your R is just equal to your rho. The same thing. Sorry. Be very careful. It's not confusing. It's very confusing. Yeah. Wait a minute. I repeat. Rho is something measured from here up to here. So in this case, this is your R, okay? But this R, rho, this is rho, sorry. This rho is just equal to your R here. It's just the same thing. If you really measure that, the length will be the same. So this is for sphere. But if you want to differentiate these two, okay, want to differentiate, let's take a cone. A cone is something like this. This really give you the idea of in what sense that error is not the same as error. Error is not the same as rho. Sorry. So this is rho. This is error. Of course, this is also error. You can also say this is also error. So error is basically we use it at the projection regions, okay, because this is the projection region so for this cone. But rho is something different. This here up to here it is rho. This also rho. So from here you can see here the rho obviously is not equal to error. Did it make sense to you? Rho is the distance between origin to the surface of the object. Yes, correct. Or whatever Patrick say in the chat room is correct. Rho is something in the layman explanation. It is a distance from the origin to the surface, or not to say to the surface because this is to this part. Okay, but cone is actually to here. To the surface, you can say the surface are one of the surface of that. It make sense to you? But error is only used in basically is used for circle only. Error is used for circle. The best here is circle, but obviously this is not circle. Yeah, this is not circle, right? So this is a distance, something from the origin to the surface of the object. So that's the first thing you have to differentiate or distinguish between error and also rho. I repeat, in some case like sphere, they are the same. Sphere including hemisphere, they are the same. But in cone, they are not the same. Just okay? So this is the most difficult part of this learning unit. And the second one is rho, sphere. This is pronounced as sphere. Sphere. So nowadays that we are this Greek letter become become very common in our life. Okay. So this is phi. Hopefully we don't have this. We have delta. We have omicron. We don't have phi. Hopefully we don't have that so much Greek letter. So this phi is pronounced as phi here. So phi is something that you look at this one. Theta is still the same. Theta in this case are still measured from here, but phi are something measured from Z positive. From Z positive. So phi you measure from positive Z axis. Okay, so measure from here. What does that mean? We measure from here. If it is cone, if it is sphere, it is cone easy. I use cone. It's measured from here up to here. Then this is your phi. But for sphere, you measure starting from Z positive from here up to here. This is your phi. Then you notice that, okay, one thing we write here, phi is something from 0 to pi only. It didn't go for 2 pi. The most that you go is only up to pi. Why? Because you have to treat this everything symmetry here. Okay, for sphere, you go up to here from 0. If you go up to here, is up to pi over 2. If you go up to here, your phi is go up to pi over 2 only. Sorry, pi. Let's go up to pi. For con later on, we will prove that. Okay, don't worry about the range for this phi. Okay, so what you should know here, the phi is something you may either you can measure this direction or measure this direction. You can have that. If you measure this direction, it will become 0 to or negative pi. It will become negative pi to 0. Or 0 to negative pi, the same thing. Here you go this direction is negative, you go this direction is positive. So that's about phi. We will find the phi for this con later on. Okay, so I'm not going. Just simply tell you that the phi for this con is from 0 to pi over 4. Up to here is 45 degree. But you can go for this as well, but we normally go for this direction in order to get a positive value rather than negative. Is that okay? I repeat. Phi is something you measure it from positive z-axis, where you can either go this, you have to take into account the symmetrical properties. You go out to here, the most that you go is up to pi only, which is 180 degree. You don't have to go for this direction, which is you use negative direction. So same thing go for con. So that's why be very careful of the range for this phi, which is from 0 to pi only. So that's phi. Theta is still the same. Theta is still the same, okay? Theta is still the same. So far, so good. That's about parameter. Rho, similar to R, but not the same as R. Very bad when I said that this thing. Similar to R, but not equal to R. And the phi is something you measure from positive z-axis, but be very careful, the phi can go up to pi only. Can go up to pi only, very careful of that. Okay, then the second part is about the conversion formula. Okay, if you see the conversion formula, this is just slightly extend to this, you add in this part, right? You add in this part so that you have your z power 2. It's very similar, but now you put it as a rho power 2. Then the conversion formula for this is slightly complicated, the x and y and z. But if you focus on this part only, okay, if you focus on this part only, so here you will have rho cos theta and rho sin theta. You will have rho cos theta and rho sin theta. Okay, so this part here, if you change the rho into R, this is exactly the conversion formula that you have in polar coordinate. Do you agree? If we only focus on this. Okay, so if you change this to, if you say the R is just equal to the same to rho. So what is extra here, additional here is you have sin phi, okay, and the cos phi for your z. Oh, then you have to find a way that, if I remember, I put it into the formula. Okay, I can't remember. I always forget to put it in as a formula. Is it okay with conversion formula? You focus on this part. These are the same as polar coordinate, but so you have to add in this sin phi, and rho and cos phi. Of course, the z here you have to use this conversion formula. So that's the second thing. The first is about parameter. The second one is about the conversion formula, and the third one is about by itself you have this in your spherical coordinate. The spherical coordinate always come to this rho power 2 sin phi. To prove that, of course, you need to use Jacobian and so on to get this thing. But I'm not going to ask you to do the proving here. But you will remember this by itself, it is something like your r d theta. By itself, you have this r. So by spherical coordinate, you have this rho power 2 sin phi rho. So what you put here is still 1. Is still 1. It's very similar because this dv by itself is equal to this everything. The dv by itself is equal to this. Is it okay? Any question with this spherical coordinate? Okay, so thank you for response from Rebecca. So back to here, we have to make use of this conversion formula to prove that theta, phi for con is actually from 0 to pi over 4. Okay, why it is like that? Okay. Yeah, before that, we have to show that this conversion formula is correct. Okay, let's go for this. Okay, I will probably have to write it somewhere here. Okay, we go for this conversion formula. So if you have this x power 2 plus y power 2 equal to z power 2 equal to rho power 2. So we've tried to prove that, see whether this is correct or not. Okay, this left hand side, whether it is equal to right hand side. So I'm going to prove that this. Okay, then what we're going to do here, you substitute this everything, the conversion formula, into this part here. So the conversion formula will be slightly long. You have rho cos theta psi phi, everything power 2 plus rho psi theta psi phi, everything power 2 plus rho cos phi, everything power 2. Then it is just expand everything. You don't have to, we didn't do much for this step, just put it everything as power 2. It looks complicated, but later on we can actually reduce it, simplify this accordingly. Hopefully you can follow. I give you 20 seconds. And you see that these are the common factor. And you should also see that these are the common factor for the first two. You should also, so at this, I do it at the same time. This everything, if this is a common factor, I will first factor out this rho power 2. Okay. And then for whatever here, I will also factor out this psi power 2 phi at the same time. Okay, I need to do at the same time, otherwise you will have a very long, okay, line to write. So what's remain here is cos power 2 theta plus psi power 2 theta. And here, what's remain here, oh sorry, I shouldn't use a bracket here. What's remain here is plus cos power 2 phi. Be very careful. The rho power 2 are common factor for all these three terms, but the psi power 2 phi are only the common factor for this first and the second term. So if you do what we did just now, what we did is just to put this all conversion formula into this, and then you just put the square for all of the term. Then you just do the factorization, factor out the rho power 2 for all, and factor out the psi power 2 phi for the first two expression. Okay, from this, you should be able to see this thing here, everything is equal to 1. And not only that, the psi phi power 2 and cos power 2 phi is also equal to 1. Is it? Not only that this is equal to 1, I may add in another line so that you can see. So if this is equal to 1, you have rho power 2. What's remain here is psi power 2 phi plus cos power 2 phi, and this remain the 1. This remain 1. So you have rho power 2 here. So what is your feeling when you see this? Difficult? Complicated, huh? But I just like to use the word, the expression that used by what you call Gil. I can't remember the name. I think it's Gil. I can't remember the name. When I watch this badminton live, I always heard this expression. How on earth this mathematician can find this conversion formula? That's worked so well, and you get this is rho power 2. So this is the beauty of mathematics. Yeah, how on earth that mathematician can find this? Huh? Yeah, we can see that we have a very big gap, okay, in between this. Rebecca said they have nothing to do. Yes, correct. They have nothing. They have nothing to do and find this formula. Yeah, I agree with you. So mathematicians make our life difficult. Okay, they have nothing to do yet. Then they do this one and they find this. Yes, yeah, it's very, yeah. So this is the conversion formula. Okay, the conversion formula, and they get this. They get this. They get this. Summarize this all this x, y, and z everything into rho power 2. Okay, but don't you worry. Or whatever I show to you, this is just for explanation. I'm not going to ask you to prove that. Oh no, it will not be. The proving question is not okay. I just explain to you this one. If you can't follow, then that is still okay. Okay, if you can follow, then you know that you can appreciate the use of what you call the trigonometry identity trigonometry here. Yeah, and this is how you do the factorization and to reduce or to simplify your expression. Okay, that's the first one. Yeah, it is good that we have this online lesson for this, and you can always watch back the recording. Hopefully, the recording, I'm not sure I can still have the quota to do the recording or not. Okay, I record, but I'm not sure whether it's really work. So, but anyway, this is the first thing that we want to show that the conversion formula. The second thing that we probably have to do, and then just for the demonstration, is to show to you that the phi is from 0 to pi over 4 for coin. For sphere, you don't have to do that because you know that it's either upper hemisphere is up to pi, and then lower hemisphere is you have some other things. But I just want to prove that this phi. Yeah, before that, we go for something easier first. If you have a upper hemisphere only, okay, then the phi is from here up to here. This phi is from 0 to pi over 2. Okay, but if you have a lower hemisphere, okay, so if you have a lower hemisphere, you have your phi from here up to here. So your phi is from pi over 2 to pi. Pi over 2 to pi. But now we want to go for con. Okay, for con, you have to go for this formula. And you know that the con is this formula, right? So you go for con here, this formula, where you have your z equal to this formula, the standard con. I'm saying that on the standard con, you have this one. So of course you can, for convenience, you just factor out you just eliminate the square root, okay? Eliminate the square root, and so you have the z power 2 here. And what is z? Z is this one, rho cos theta. So this part here, you have rho cos theta, and I straight away put that as a power 2 to reduce the number of lines. Then the same thing go for this, because we already eliminate the square root. We have x power 2 and we have y power 2. So it's exactly this one. So I straight away go take this and take this, okay? I straight away take that. So you have rho cos power 2 theta psi power 2 phi plus rho power 2 psi power 2 theta psi power 2 phi. Okay. You know that we are only interested for this one for this stage. We are only interested on this rho phi parameter. So what you can see here, the rho power 2 are all common factor at the left and the left hand side, also right hand side. So you can just cancel off. In other words, here you divide rho power 2 both sides to cancel off that. Hopefully I'm not too fast. And again, this is for demonstration only, to show to you that the phi for the con is pi over 4. Then the left hand side, you have this one. And the right hand side, you can see here again, you have your common factor. You have your common factor where you can actually factor out. So if you factor out here, you have the psi power 2 phi, and here you have cos power 2 theta plus psi power 2 theta, which immediately it is implied that this everything is 1. Is it okay? We use this identity trigonometry. Then, okay, once you have this, we may keep that this psi power 2 phi over here. Okay, and if I bring down my cos power 2 t, cos power 2 phi here, I bring down this. Of course, you can write down this is equal to 1, but I'm going to write somewhere here. I'm going to write somewhere here, so that it is but nothing, yeah. You can write it later on. Just write it later on. It's just equal to 1. And you know that this one, it can be simplified as tangent power 2 phi equal to 1. Is it okay? And tangent power 2 phi equal to 1. And this phi, of course, here you can find that the phi, when tangent will be 1, it is obviously it is 45 degree. When tangent is equal to 45 degree, you have when phi is equal to 45 degree, you have tangent phi is equal to 1. Okay, so that's why the phi here is equal to pi over 4 for a con. Did it make sense to you? So we take about 30 minutes and 25 minutes to explain, just to explain the parameter of sphere and explain the conversion formula and explains especially the parameter phi. Make sure that you know how to get your phi. For your sphere is this one. For your upper hemisphere is this. Lower hemisphere is this. Cone is this. Okay. You don't have to repeat this one. You may just use directly. So far so good. Are you still with me? Or you are worried on something else? Kelvin Wong. Yes. Okay. Two questions. One question is on Rebecca asked us on this tangent power 2. Okay. You may try to read it this way. This is your tangent. If you want to put it this way, okay, it is still 1, right? It is still 1. So if you put your 1 over here, you have plus minus 1, but here we just consider tangent is equal to 1. We just consider tangent is equal to 1. So hopefully I answer Rebecca question. So you can, I'm probably skip a lot, okay, a lot of steps here. In fact, what you can do here is you can square root both sides, okay, you can square root both sides so that you arrive at this one, or you arrive at this one if you want. Yeah, and so you will know that the tangent. Of course, the phi here you can take a lot of different value. If you want to take this, okay. If you want to take this pi over 4 plus 2 pi, yes, you can, because this trigonometry, if you remember that this is a periodic, right? It's a periodic function, so you may has different value, okay, but okay, we just take the principal one, which means that this is the simplest. If you go for this value, which is 9 pi over 4, you can, but you make yourself difficult. Okay, so we have pi over 4, so this is 4. Hopefully, Rebecca, you can understand this. And Kelvin asked on how is loop when the cone reach phi is pi equal to 4. So it's very good question. It's very good question. So now I have to emphasize on these two things. The first one is I only say that, okay, this pi over 4, listen carefully. This pi over 4 is only applied for standard cone. What I mean by standard cone here is this is 1, this is 1. If this is not 1, this is something like if you have 2, then you cannot say that phi is up to pi over 4. You have to calculate this one again, which is very difficult. Is that okay? The first thing, this phi from 0 to pi equal to 4, pi over 4 is only applied for standard cone. What I mean by standard cone here, this is really a circle. This is really a circle. This is not ellipse. The cone here can be ellipse as well. This is not ellipse. The cone here can be ellipse, but this is not. Because this is not necessarily a standard circle. It can be an ellipse, okay? It can be an ellipse, okay? If you have your cone, you try to kemitkan dia, okay, then it is an ellipse. But we refer this to a standard cone where the standard cone meaning to say the coefficient here is always 1 and 1. If it is not, then it is not pi over 4. That's the first thing. And the second thing that I want to tell you is that, okay, now you should understand here, the phi here is strongly controlled, the rho here is strongly controlled by phi. Okay, this one I have to highlight. I zoom this down, the cone. Sampai besar-besar. Hopefully you can see. Besar sangat my cone. Uyuh, besar betul. I have to quickly add in this one. Now you should be able to see. Okay. There are many phi here. There are many row here. From here up to here, this is row. Okay. From here up to here, it is also row. Okay. But now you have your first phi value. Or let's say you say it is phi equal to something. And this from here up to here, it is also your this is also your phi. This is also your row, and you have another phi value. So in other words here, row is depend on phi. Did it make sense to you? If you have a triangle like that. So row is depend on phi. So that's the idea that you need to know, or how it's depend on how you calculate that later on. So Kelvin said agree. Hopefully the rest you agree with me as well. You are forced to agree with me. Oh, but we don't have that in R, right? R is not depend on theta. Do you agree when I say R? If you have this thing, your R is not depend on your theta. R is not depend on your theta, but your rho now could depend on your phi. Could, I say could. Especially in the con. We spent 30 minutes to explain this everything, spherical coordinate. So you can see that I think you agree with me that this is the most challenging part of this multiple integral. The one that before this is what you have is your the double integral and triple integral are all the senang-senang kan, bersenang-senang dahulu, bersusah-susah kemudian. Okay. Yeah, you can always come back to this, but we have to go for one example now. This example. So we may be able to. I think we can only discuss one example, and then before we then I will stop. Okay. So this one. So what we want to find is find a volume of the solids bounded by sphere. Okay, then you quickly sketch your sphere. Okay, which is here. From here, you should know that it is radius 4. Okay, radius 4. And below by con, don't too worry about that. You know that the con is something like this. Okay. So what we want here, okay, what we want here is just a volume bounded above by sphere and below the by con. So it should refer to this part. You try to read again. A volume of the solid bounded above by sphere, and below by con. In other words, here you have this solid is all about you can use analogy. It is an ice cream cone plus ice cream, plus the ice cream, the topping here. Is it okay? It is an ice cream cone plus the ice cream. Okay. Then we have 3 parameters to use. The first is about rho. Okay, from here you can see here definitely rho will always be the same. Rho will from 0 to 4. the row, because this is row. I'm not going to write here. This is row. This is also row. This is also row. So no matter which row that you choose, it is always 4. Then you have theta. Okay, so this one come together with the projection regions. Oh, this one come with the projection region. You know that this one. So this is all this part. So x and y. So from here along, you should know that the theta is from 0 to 2 pi. Okay. Notice that we are not interested to know how big this circle is. We are not interested to know how big this circle is because we do not have to use error. Error is not needed here. So that's why we don't have to find how big this, what is the radius here. I hope you can see the difference, because we have rho already in spherical coordinate. We don't have error, so there is no need for you to find how big this circle is. Okay, just enough for you to know that it's cover 4 quadrant. Then you can make your decision saying that this is theta from 0 to 2 pi. And then the next one is phi. Phi is something from here up to this one. So this is your phi, and you know that this is a standard cone. You know that this is your standard cone. Then you should know that your phi is from 0 to pi over 4 because of the standard cone. A standard cone is meaning that you didn't see any 2 here. You know that this part, the base of the cone, will give you a circle, but it is not an ellipse and so on. So that's why with that, you can have your 3 limit already. Is it okay? And we want to find volume by using this formula. We want to find our volume with this using this formula. And then you should know go one by one. Okay. For this, again, we always go for theta at the last one. Because theta, in most of the case, it will always constant. Okay, so you have go for theta. Then you go for phi at the second one. The phi is from 0 to pi over 4. Then we have the rho is from 0 to rho equal to 4. Even though this is 1, but by itself, you know that your spherical coordinate, you have the rho power 2 sine phi to integrate. Okay? And you have to integrate with respect to rho, phi, and theta. Is it okay? So if you're able to write down this, okay, this triple integral, you are almost there. Or just to solve this equation, just to solve this integration. This, of course, is challenging as well, because you look at the equation here, it's already quite challenging. Can I repeat? You have your theta, you have your phi, you have your rho, then you have this everything. So what you need to do here is to integrate this with respect to rho. So you can factor out your phi, your sine phi, and this everything is rho power 2. So you have rho power 3 over 3 from 0 to 4. and this is d phi d theta. Then you know that this everything we give you 4 power 3 is 64 over 3, so it is just a constant where you can take up that. Okay, so this one here you have integration for 0 pi over 4 psi phi d phi d theta. In fact, you can straight away do the integration of psi phi if you want. So here you know the answer here. Okay, the answer for this, we give you negative cos phi from 0 to pi over 4. So I may just focus on this part only. Here you have negative cos pi over 4 minus negative cos 0. Minus negative cos 0, where this one we give you 1. This cos pi over 4 is exactly this, where you have your pi over 4, 1 third 2. So this is 1 over third 2. So this will give you 1 over third 2. So overall, this will give you 1 minus 1 over third 2. I hope you can follow this. Yeah, you need some of course, you can use calculator. Or you can use calculator and have the answer in decimal numbers. I accept as well. Okay. But I want to see this thing. I want to see this one. If you use calculator, finally you get one marks for the numerics value. It's okay, but you're missing this. But it is okay. I'm missing 1 marks because here is 1, 2, 3, 4. This is 4, and your diagram is 5 marks. Okay, you may leave it in this form if you want. So here you have 64 over 3, 1 minus 1 over 2. And here, this everything you know that we give you 2 pi. So here we have 2 pi. You may just leave it in this form if you want, or if you can also put it this way, but it's just the same thing. Why I say it's just the same thing? This answer is obtained basically by simplifying this. I don't want to disturb this, so I go for this again. You can leave out the answer in this form, but if you want to go further, this is the way. If you want to go further, so what you need to do here is equating denominator. Okay, and you can also change this to pi to third 2. So where everything now will become 64 over 3 third 2 divided by third 2 minus 1. Then you have your third 2 pi. This and this can be cancelled. Then you multiply this again in. You multiply this again with this one, multiply again with this one. So you will arrive at 64 over 3, 2 minus 2 pi. But it is not necessary. You may just leave your answer in this form. It's good enough. Any question? I make it smaller so that you can print screen this on as a whole. I'm going to stop after this. Okay, I think it's enough. We still have one question and a few questions to go for the spherical coordinate, which probably require another 2 hours for us to complete that. Okay. As I say, spherical coordinate is the most difficult one, most challenging one. This is mainly to differentiate whether you are A student or A minus student, or probably B in between that. Okay. So if you feel that this is it is very difficult for you to follow, you may just focus on the rest. But for sure, you will have spherical coordinate question either in your test or final exam. It is not that easy for you to follow and for you to do all this, okay, to get the parameter, to get the correct integration. I know it's not that easy, and also the correct graph, okay. So you have to do some exercise on that. Do some exercise on that. So if no question, then you may leave this platform and enjoy your semester break. Since all of you going back to your hometown, then remember to bring, if you come back to Unimas, and remember that your lecturers are still working, okay, throughout this semester break, okay. They have no holidays. You may, if you are from, there is one question from Patrick. A very good question from Patrick that I would like to answer this. The Patrick asked me whether this and this is the same or not. I will say it's not the same. This is a phi, this is sine. Oh, I'm very good in Greek. I am very great. I am very good in this Greek letter. You know why? I had the chance to go to Greece many years ago. I went to Greece. Okay. When I went to Greece, the problem with this is I can't even read their writing. There are many Greek words, especially that express their toilet in this. I don't even know that. It's a very beautiful country, but unfortunately, I didn't go to Athens. I didn't go to this, what you call, there is a very beautiful islands there. I didn't go for that. I go for Thessaloniki. If you can't, I can't remember. This is the second largest city in Greece. Why they like to use Greece, I have no idea. Don't ask me that. It's a very beautiful country. I still remember I stopped over in Istanbul before I go to Thessaloniki. It's a very beautiful journey, the best in my life. Of course, the best, not the best. If I say the best in my life, then it's probably not fair to my wife. Okay. So a very beautiful place, of course, a very beautiful place. So, they like to use Greek letter. I have no idea. You have to ask mathematician. They make your life difficult. Okay. A lot of Greek letter, very common in mathematics. They look very high class. No. It's difficult for you to read the Greek letters, but it is used a lot in mathematics. If you don't like, you just change this to others symbols that you want. This is something like this, which is not very good as well. A lot of these symbols. Mathematics is all about symbols and notation. So I'm not going to say a lot on this, but so you just start to save money. This one, again, so Rebecca asked me on this. I have no idea. Maybe I'm wrong. I can't remember this. You Google this. You just Google these things. The Greek letter. This is not in record. So you just Google this one, and this is Greek letter. Letters. A lot. Okay, we have a lot now. Which one is better? This you have a lot. You can see here. It's true that you have so many letters here. There's 20 more. This is a very good thing. It's even tell you that how they pronounce. Just now, what is that? Someone asked me on this. I forgot. Oh, very bad. This is even lowercase and uppercase thing. This is phi, this is also phi. You look at this one, these both are also phi. The one that asked by your friends, all are phi, but that is, these are, what else just now? Where am I here? These are psi. These are phi and these are also phi. Both of these are phi. Oh, I forgot. Yeah. What is that? Oh, this is psi. I made mistake here. Mistake. Oh, this is psi. This is also phi. Very bad. This is also phi. These are also phi. Just that this is lowercase. This is uppercase. Am I correct? What is your reaction this far is here? Yeah. If you want to learn this, go and visit Greece. It's easy. If you come to here, you have ways. And yeah, Omicron, you see that Omicron is this one. Omicron is this. Then we have, of course, every one of you know Kappa. You have also lowercase and uppercase. Epsilon, you have this one. Okay. Omicron is very basic. Why? I'm not sure whether this is correct or not. Whether it is O or sigma. Sigma is this one. It's terrible. This sigma is the if you are omega, you have the omega here. This is omega lowercase. This is uppercase. So it's difficult. Lower and uppercase. You go and learn that by yourself. If you can't remember this, then you design a T-shirt for this. Design a T-shirt so that you have all this. Okay, that's all for today. Thank you very much for your patience. And if you are from Terengganu, remember when you come back here, bring the Terengganu, the kelopak lego to me. And if you are from Johor Bahru, from Johor, from Muar, don't forget to bring otak-otak. Okay, I nanti rasuah. If you are good to me, I'm good to you. Very bad. Cebu Kangpo also can, no problem. Yeah, I welcome everything. Yeah. Okay. Enjoy your semester break. Yeah. Okay. So that's all. Thank you. Bye bye.